Algebra 2, review of Unit 5. This was quadratic functions. So a couple of big topics. We started out with everything that had to do with complex numbers. So everything you see here sort of represents what we did with complex numbers. There is a definition of I. Everything we did in complex numbers is based upon that. The real and the imaginary parts of a complex number. Add, subtract, multiply complex numbers. I to some power. How do you figure out what that is? Definition of and how to find a complex number's complex conjugate, and because you use that to divide complex numbers, okay? Then we moved into graphing quadratics, okay? We graphed vertex form, okay? And we graphed intercept form and standard form. You need to know those forms and how it differs with the information you're given and how you graph. So from any form of a quadratic, find the vertex, the direction of opening, axis of symmetry, y-intercept, finding the x-intercepts if it's in intercept form, and then from any quadratic, not only graphing the quadratic, but if it showed up as an inequality, how would you graph that? Where would you shade? And would the parabola be dotted or solid when you graphed it? Okay, so those are in a nutshell all of the things we did. Adding complex numbers. This question has been on the test the last few years, and sometimes people foil this, but please don't miss that. This is subtraction, okay? We are not multiplying anything. So this is 2 minus 4i minus 1 plus 1/2 I, okay? So it's just distributing that minus sign. If I combine the real parts, 2 minus 1 is 1, and sorry, that is an I. So 2 minus 1 is I, and 2 minus 1 is 1, and then minus 4 plus 1/2, that's going to be what? Minus, you could write it as 3.5 I. The other thing, you could write that, so that's a perfectly good answer like this, or you could write this as, 1, you could have minus, 8/2 I plus 1/2 I, and so that's minus 7/2, so 1 minus 7/2 I. These are both equivalent expressions, okay? Next one is actually multiplied together. So to FOIL this, you multiply the first two terms together, you get 4i. The outside terms together, you get 28. The inside terms together, minus 3i squared. The last terms together, minus 21, 21i. And then I just need to combine like terms. 4 minus 21, that's minus 17i plus 28 minus 3. I squared is negative 1. So this is negative 17i plus 28 plus 3. So this is negative 17i plus 31. All of our answers are in the form a plus bi. So real part, 31 minus 17i. Multiplying these guys together, this looks like I squared times 1 minus I. What is I squared? That's negative 1. So negative 1 times 1 minus I, that is negative 1 plus I squared. Excuse me. So negative 1 times 1 is negative 1. Negative 1 times negative I is just plus I. So this answer is negative 1 plus I. I to the 702nd power. So all you really need to do, you need to know how to divide 702 by 4, and then whatever your remainder is. 4 goes into 7 one time. That leaves you a 3. Bring this down. It goes in there 7 times. 28, that leaves you a 2. Goes in there 5 times. That's 20 with a remainder of 2. So my answer is going to be I to the remainder, I squared. Another way of thinking about this is I to the 4th to the 175th power times I squared. That's just a big fancy way of writing 1. So this is just I squared, which is negative 1. Here we have subtraction again. So 1 plus 2i. And what some people do is just like, so instead of writing it all out from left to right, Then I'm going to have what? Minus 2i, and then minus minus 1, that's plus 1. Add all these together, and your answer is 2. I to the 76 power. So 4 goes into 76, goes in there 1 time. 4 goes into here 9 times. Remainder is 0. Okay, so so this tells me my answer is just going to be I to the 0, which is 1. And the last one, where you are rationalizing or dividing by complex number, means you have to multiply by the complex conjugate. So there's 3 plus I over 2 minus I. This has to be multiplied by 2 plus I over 2 plus I. And then you FOIL the numerator and the denominator. On the top, you're going to get 6 plus 3i plus 2i plus I squared. On the bottom, you get 4 minus 2i plus 2i minus I squared. So on the top of that fraction, I'm going to have 6 plus 5i minus 1. And the bottom, I'm going to have 4 minus negative 1. So this is going to be 5 plus 5i over 5. So that's 5 over 5 plus 5 over 5i, which is 1 plus I. 2 over 1 plus I. I need to multiply by 1 minus I, 1 minus I. So I get 2 minus 2i over 1 plus I minus I squared. So that's 2 minus 2i over, on the bottom, I'm going to have 2. So this just becomes 1 minus I. And then I think we move into our graphing, okay? You really need to be solid on these forms. Sometimes when I was this age, I would write my formulas first thing on my test so that I knew them. So this is the formulas: y equal a, x minus h squared plus k. The vertex of this parabola is hk. The axis of symmetry is x equal h, okay? So does this parabola open up or down? It's got a negative sign in front of it. It goes down, okay? What is the axis of symmetry? That's the line x equal 3. What you can also do is when you find something, go ahead and graph it. There's the axis of symmetry, okay? What's the vertex? The vertex of this guy is 3, 4. So 3, 4 is right there, okay? What is the y-intercept? The y-intercept is what you get when you set x equal to 0. So in this equation, if x is equal to 0, you're going to get negative 3, what, squared, plus 4. So that's going to be what, negative 9 halves. So negative 9 halves plus 4, which is negative 9 halves plus 8 halves, which is negative 1 half. So my y-intercept is 0 minus 1 half. So 0 minus 1 half is right about here. So I'm 1, 2, 3 to the left of that axis, 1, 2, 3 to the right. I should get the same value, okay? Then let's just pick a value for accuracy. If I'm sitting here at 3, let's just see what happens at 2. What value do I get when x is 2? When x is 2, substitute that in this equation, and I'm going to get what, negative 1 half plus 4. That's 3.5. So at 2, 3.5, 1, 2, 1, 2, 3.5, which is right here. That puts me about right here as well. So I can see this graph doing this. Okay. What is the domain of this function? Don't miss this because every domain on these parabolas is negative infinity to infinity. The range of this guy is negative infinity. Highest y value I see there is 4. Okay, and then we can move on. Another one. Now this one, if I see this is an inequality, okay, I'm still in vertex form, but I've got an inequality. But which one, what inequality is it? So it's the same one that I just graphed, okay? So I can save a lot of time here. It's the same thing that I just graphed, okay? So if I look at this inequality, this needs to be a dotted, okay? Well, if I could spell dotted, it would help. When I draw this parabola, I need to graph it with a dotted curve. So let's go back to what this was at 3, 4, which was right here. And then I think at 2, 3.5, right there. And I think it was 0. I was at what, 1/2? The y-intercept was 0, negative 1/2, sorry. So 0, negative 1/2, which was right here. So 1, 2, 3, 1, 2, 3, somewhere right in here. Okay, so when I draw this parabola now, this dotted line. Okay, and now the question just becomes, and I need to be a little bit more careful over here on this side when I graph this guy. Remember, it was at 0, negative 1/2. So remember, it's going to go under that 0, 0. Okay. So I need to look and see. Now I've got to figure out, where do I shade which side of the parabola? The way you do that is you test it with the point 0, 0. So substitute a 0, 0 in for x and y. So is 0 less than negative 1/2 0 minus 3 squared plus 4? Okay. And what do I get on the other side over here? So when I plug in a 0 there, that's my y-intercept. It was negative 1/2. Is 0 less than negative 1/2? Answer is no. So 0, 0 is not a part of my solution. So this is my solution, okay? So this one, you had to be real cautious about your accuracy here. If you drew this to where, like I said, if I drew this like this and I thought 0, 0 was in there, I would be shading something different. So that one took very, very concerned care about how that was graphed, okay? Give the requested information and graph this next quadratic. This one is in intercept form. That form is y equal x, x minus p, x minus q. I've got intercepts at p0 and q0. My axis of symmetry is p plus q over 2, okay? So this parabola is going to open upward. The axis of symmetry, okay? The axis of symmetry is going to be, let's first write the x-intercepts. The intercepts are going to be at 2, 0 and negative 6, 0. And then the axis of symmetry is x equal 2 plus negative 6 over 2. That's negative 2. So at negative 2, that's this line right here. That's the axis of symmetry. And my intercepts are going to be at what? 2, 0 right there, and negative 6, 0. And that should be symmetrical. It is. It's got to open up, so that means the parabola, the vertex has to be lower than this. To find the vertex, you're going to plug a negative 2 into this equation. So 1/2 and negative 2 minus 2 times negative 2 plus 6. This is 1/2 of negative 4 times 4. So that's negative 16 divided by 2 is negative 8. So vertex is right there at negative 8. So the vertex is at negative 2, negative 8. I should have enough to graph this guy. I could put in 0 to get the point for the y-intercept. If I did that, I think it's at negative 6. I could find that point right here. So, and that would just sort of help me draw this even better. Domain, negative infinity to infinity. Range, negative 8 to infinity. Okay, next thing I'm asked to graph the inequality. Okay, it's the same parabola that I just graphed. Okay, it's going to be a dotted line. Okay, so let's just regraph this guy. What was it going to be at -2? So 1, 2, this was the axis of symmetry. And -8 was right here. And what, -6 and 2 right here. So graph this with a dotted curve. And then just test 0, 0. Is 0 greater than 1/2? 0 minus 2, 0 plus 6. So is 0 greater than, this is going to be -6. Is 0 greater than -6? Yes, it is. So the solution is going to include 0, 0. So that is the solution for that inequality. This is in standard form. So standard form, y equal ax squared plus bx plus c. Axis of symmetry is -b over 2a. The y-intercept, so the y-intercept is the point 0, c. This parabola opens up. The axis of symmetry is x equal negative of -4 over 2 times 1, which is 2. So x equal 2 is the axis of symmetry. Okay. The y-intercept is the point 0, -1. So right here. So I know that if I've got this point also right here. To find the vertex, just plug 2 into that equation. So you're going to have 2 squared minus 4 times 2 minus 1. That's 4 minus 8 minus 1. That's 4 minus 9. 4 minus 9 is -5. So the vertex is 0. Excuse me, not 0. The vertex is 2, -5. So at 2, -5 is right here. And that should be enough to graph this guy. Domain, -infinity to infinity. Range is -5 to infinity. And then graph y less than or equal to x squared minus 4x minus 1. So it's the same parabola, but graph the inequality less than or equal to. So if I just recreate what I did here, that was at 2 and 5. So at 2, -5, that's my vertex. And then I found, what were the other 2 points at 0? The x-intercept was at, I believe, what, -1? Excuse me, y-intercept. Y-intercept was at -1, okay, which was right here and right here. Less than or equal to, that's going to be a solid curve. And then I just need to test, is 0 less than or equal to 0 minus 0 minus 1? Is 0 less than or equal to -1? That is not the case. So the origin is not part of the solution. The solution is everything that does not have the origin in it. Okay, so it's everything outside this parabola. And that is it.